Hi, my name is Tiffany Nguyen, and this summer I was working as an EPSCoR intern at the University of Iowa. I was working with Jerry Mount and Professor Dave Bidditt on creating an online workflow environment. So this summer I was developing a web page using programming languages such as HTML, CSS, JavaScript, specifically jQuery, and Python. HTML and CSS were for developing the web page aspect, while JavaScript and specifically jQuery and Python were used for connecting the wind sensors that we were talking with the web page itself. jQuery was also used for animation and drag and drop sorts of things that you will see later in this presentation. Some objectives and points that I will be talking about during this presentation for this summer were to create a live information workflow, a dynamic workspace or information dashboard, and an eco-friendly house in an educational game. So workflows. Workflows are essentially how the wind sensors communicate to the users. So it's essentially how the sensor data becomes the representations of that data for the users. From the wind sensors to the databases, we have here's a zoomed in version of this system. So every 10 seconds, the sensors sends data to the envoy, which is essentially a receiver that will eventually compile the data together every minute. So every minute, this envoy sends the package of data to the SQL server. And also every minute, the Python will request that data, the SQL server will return that data, and the Python script will send that information to Postgres and MongoDB databases. So how it creates contacts from the databases to the users are events. There are 3 events here, as you can see: jQuery, WSGI, and leaflet. These events are triggered upon web page loading, or on a button click, for example, by the users. The leaflet, if you follow the red line, travels, once triggered, it will trigger and send data to the GeoServer, which is essentially what converts the data to a map, geographical map, which calls out to the Postgres database, which returns the data to the GeoServer, and then the GeoServer converts that data that it receives into a map, as you can see following the red line. If you click on this map, actually, particularly the sensors, you can see more information about either the sensors or the wind data. If you follow the green line, the jQuery event actually uses the WSGI event. The WSGI event returns a JSON file, which is essentially all the data that you can receive from the database. So once the jQuery asks the WSGI file, which is essentially a Python script for the data, the Python script calls out to the Mongo database, which then returns the data, and then the Python returns that data to the jQuery script, which then converts it into a table, as you see at the very bottom, displaying all the data that was returned. So for information dashboards, this connects to the workflow concept that I was talking about earlier. You can use the information from the workflow to display various things, such as live graphs and a live map, and also another sort of workflow area that you'll see in the next slide. Other ideas or widgets that I created in this dashboard are seen on the right-hand side of the image on the screen. These little widgets are drag and droppable, so you can drop it onto the area in the middle where you can see currently a live graph is dropped. And you can design a whole page that you can eventually display, for example, presentations or for research in the classroom or in the research context. You can also drag and drop YouTube videos, texts, which you can edit, and pictures that you put on, as well as a live map. You can also drag and drop an animated interactive representation of how the data is passed from the sensors to the users. Here, it's essentially the same thing as the workflow. However, you can move these little dots around and create an image that you prefer, for example. The green boxes around the dot in the middle are actually live data from all the sensors around campus, and will update as the data updates and is sent to the file, to the event. Another one that I haven't put on here because we haven't quite implemented is the Impress software, which is essentially it's essentially like PowerPoint, and it's a presentation software, so that if you put it on, if you click on it, you can change and animate from slide to slide, showing various pieces of information, such as you can put a web page on it actually and interact with it. So here's an example of a completed workspace. You can see the graph and the map. And the map, both of these are interactive, so you can hover over the colors, for example, to change the color to see what you're hovering over, or you can even drag this map around to see various areas of the Iowa campus, for example. The last aspect that I will be talking about are the educational games. We have created a design your own eco-friendly house, and we were trying to model different behaviors of energy within a house. So here you can see a drag and droppable interface. You can drag the objects on the right-hand side into the house and create your own house, really, with different rooms, with doors, with windows, with different appliances. You can also model the behavior of these appliances, which relates to the energy usage simulation as the second bullet point. And by this, I mean you can choose how you want the appliance to work throughout the day. For example, the refrigerator will be running all day at X watts every day, every hour, while other appliances may be used at different times depending on how a person wants to use it throughout the day, to simulate how people actually live, if people actually live in the house. You can also visualize energy flows throughout the house to see what rooms, for example, are taking up the most energy and where the most inefficient places of the house are. So that is my presentation. And if this work was supported by the Iowa NSF EPS Core Grant.